How did they do it? For over 4,500 years, the Great Pyramid of Giza has stood as a silent testament to human ingenuity, a colossal puzzle that continues to baffle engineers and historians alike. Today, we're diving deep into the seemingly impossible engineering feats that brought this ancient wonder to life. Forget what you think you know, because the truth is stranger and far more impressive than fiction. The sheer scale is the first thing that hits you. The Great Pyramid is made of an estimated 2.3 million stone blocks, each weighing between 2.5 and 15 tons. Some of the granite blocks in the King's Chamber, transported from quarries over 500 miles away in Aswan, weigh up to 80 tons. To put that in perspective, 80 tons is the weight of about 12 adult elephants. How on earth did they move these massive stones with just muscle, wood, and rope? The common theory you hear is that they used long ramps. But let's break that down. A simple, straight ramp would have to be over a mile long to maintain a manageable gradient. Building such a ramp would require almost as much material and effort as the pyramid itself. Plus, where would it even fit on the Giza Plateau? Other theories suggest a spiral ramp wrapping around the pyramid as it was built. This makes more sense, but it would have made surveying and maintaining the pyramid's precise angles incredibly difficult. You'd essentially be building blind. Recently, a new theory has gained traction, one that is both elegant and mind-blowing: an internal ramp. In 2007, French architect Jean-Pierre Houdin proposed that the builders constructed a straight external ramp for the bottom third of the pyramid. Then, they switched to a corkscrew-shaped internal tunnel to haul the blocks to the top. This would explain the lack of evidence for a massive external ramp and also solve the logistical nightmare of maneuvering heavy blocks at great heights. Scans of the pyramid have even revealed anomalies and spiral-shaped voids that support this very idea. It's like the Egyptians left a secret blueprint hidden within the very walls of their creation. But moving the blocks is only half the battle. The precision of the Great Pyramid is what truly elevates it from a big pile of rocks to an engineering masterpiece. The base is an almost perfect square with side lengths of about 756 feet. The difference between the longest and shortest sides is less than 8 inches and accuracy of over 99.9%. Each side is also almost perfectly aligned with the cardinal directions: north, south, east, and west. The deviation is less than 1/15 of a single degree. Modern construction companies with GPS and laser technology would be proud of such precision. How did the ancient Egyptians, with their simple tools like plumb bobs and sighting rods, achieve this? It's believed they used a combination of solar and stellar observation. To find true north, they might have tracked a star's rising and setting points and bisected the angle, a method known as the circumpolar star method. For leveling the massive base, they may have created a grid of water-filled trenches. By marking the water level on all sides, they could establish a perfectly flat foundation to build upon. Simple in concept, but incredibly difficult to execute on such a grand scale. Let's venture inside. The internal structure is just as remarkable. The passageways, like the Grand Gallery, are architectural marvels. The Grand Gallery is a tall, sloping corridor leading to the King's Chamber. Its ceiling is a corbelled vault, where each layer of stone slightly overlaps the one below it. This design brilliantly distributes the immense weight of the stones above, preventing the passage from collapsing. It's a technique that showcases an advanced understanding of structural mechanics. And then there's the King's Chamber itself, a granite box built to house the pharaoh's sarcophagus. Above it lie 5 relieving chambers. These aren't rooms you can walk into. They're empty spaces separated by massive granite beams. Their sole purpose? To deflect the millions of tons of pressure from the pyramid's apex away from the ceiling of the King's Chamber below. This was a sophisticated, preemptive solution to a complex structural problem. They weren't just building for their time. They were building for eternity. But perhaps the most baffling mystery is the mortar. The stones of the Great Pyramid are fitted so closely together that you can't even slide a piece of paper between them in many places. Yet, they used a mortar. Analysis shows it's made of processed gypsum, but its chemical properties are so complex that we still can't fully replicate it today. It's incredibly strong and has helped preserve the pyramid through earthquakes and millennia of wear and tear. This wasn't just ancient cement. It was a form of chemical engineering. So, when we look at the Great Pyramid, we're not just looking at a tomb. We're looking at a masterclass in project management, logistics, astronomy, mathematics, and materials science. They quarried, transported, and lifted millions of tons of rock. They achieved near-perfect alignment and precision using the sun and stars. They designed sophisticated internal structures to manage immense forces. And they bound it all together with a mortar we still don't fully understand. The people who built this were not a primitive workforce. They were skilled laborers, engineers, and scientists, highly organized and brilliantly led. The construction of the Great Pyramid would have been the equivalent of the Apollo program of its day, a national project that pushed the absolute limits of technology and human capability. The mysteries aren't all solved. We're still discovering new chambers and learning more about their techniques. But the more we learn, the more our respect for these ancient engineers grows. The Great Pyramid wasn't built by aliens or a lost civilization with advanced tech. It was built by us. It stands as the ultimate symbol of what humanity can achieve when we work together with a shared vision and a relentless pursuit of the impossible. What part of the pyramid's construction do you find most incredible? Let me know down in the comments. Thanks for watching, and if you enjoyed this journey back in time, be sure to like this video and subscribe for more deep dives into the wonders of our world. How did the ancient Egyptians, with just simple tools and immense manpower, build monuments so colossal they defy belief even today? The Great Pyramid of Giza, a wonder of the ancient world, stood as the tallest man-made structure for over 3,800 years. Its construction is one of history's most fascinating engineering puzzles. Let's travel back in time and uncover the secrets behind how the pyramids were built. The story begins not with giant stones, but with a grand vision. The pharaohs, seen as divine rulers, needed magnificent tombs to ensure their journey into the afterlife. These weren't just graves. They were eternal homes, launch pads to the heavens. The first step was choosing the perfect location. The Giza Plateau, a solid limestone bedrock west of the Nile, was ideal. It was high enough to avoid floods and sturdy enough to support the immense weight of the pyramids. Its proximity to the river was also crucial for transporting materials. Once the site was selected, an army of surveyors and architects got to work. Using tools as simple as wooden posts and ropes, they achieved astonishing precision. To level the massive base, they might have created a grid of water-filled trenches. By marking the water level on the sides of the trenches and then cutting the rock down to that mark, they created a foundation that was almost perfectly flat, varying by less than an inch across the entire 13-acre base of the Great Pyramid. Aligning the pyramid with the cardinal points, north, south, east, and west, was equally important and done with incredible accuracy. One theory suggests they used the stars. By tracking the rising and setting of a single star, they could find true north. They would mark these points on an artificial horizon and bisect the angle between them to find their north-south line. The precision they achieved with these methods is truly mind-boggling. With the foundation ready, the monumental task of quarrying and moving millions of stone blocks began. The bulk of the pyramids, the core blocks, were quarried right there on the Giza Plateau. Skilled workers used copper chisels and wooden mallets to carve out the limestone. They would cut deep channels into the rock, then insert wooden wedges. By soaking these wedges with water, the wood would expand, splitting the stone along the desired lines. But the most famous stones, the smooth, white Tura limestone for the outer casing, and the massive granite blocks for the inner chambers, came from much farther away. The Tura limestone was quarried from across the Nile, while the granite, some blocks weighing up to 80 tons, was brought from Aswan, over 500 miles to the south. How did they move these behemoths? The Nile River was their superhighway. The massive blocks were loaded onto wooden barges during the annual flood season, when the water levels were high enough to bring the boats closer to the construction site. Canals and harbors were likely built specifically to facilitate this process, allowing these stone-laden vessels to dock right at the foot of the plateau. Getting the stones from the quarry and the river to the pyramid's ever-increasing height is the most debated part of the entire process. The idea of thousands of people simply dragging stones on wooden sleds is the most common image, but it's more nuanced than that. To reduce friction, They likely poured water on the sand in front of the sleds. A famous tomb painting actually depicts this exact scene. But what about lifting the stones? The most widely accepted theory involves the use of ramps. However, the exact type of ramp is still a mystery. A single, long, straight ramp would have been impractically massive, requiring almost as much material as the pyramid itself and needing to be extended for miles. So, alternative theories have emerged. One popular idea is a spiraling ramp that wrapped around the pyramid as it grew. This would allow for a more gradual incline and use less material. Another theory suggests an internal ramp system, a kind of corkscrew tunnel inside the pyramid's structure, which some modern scans seem to hint at. A combination of different ramp types was probably used, a larger main ramp for the lower levels, and smaller, more flexible ramps for the upper, more difficult sections. As the pyramid rose, the precision of the builders never wavered. The outer casing stones were cut and fitted so perfectly that you couldn't even slip a piece of paper between them. This not only gave the pyramid a smooth, gleaming white appearance, reflecting the sun's rays, but it also made the structure incredibly stable. Inside the pyramid, another engineering marvel was unfolding. The king's chamber, for example, is a masterpiece of construction. It was built using enormous granite beams to form the roof. To relieve the immense pressure from the millions of tons of stone above it, the builders created 5 stress-relieving chambers, a brilliant architectural solution to prevent the chamber from collapsing. The Grand Gallery, a long sloping corridor leading to the king's chamber, is another wonder, showcasing their mastery of corbelled vaulting. So, who were these builders? For centuries, the common belief was that the pyramids were built by slaves. However, archaeological discoveries, including entire villages for the workers, have completely overturned this idea. These were skilled, paid laborers who lived in organized communities near the pyramids. They had access to food, housing, and medical care. Skeletons of workers show evidence of healed fractures, indicating they received treatment for their injuries. They were not disposable slaves. They were respected craftsmen, part of a national project of immense cultural and religious importance. It is estimated that a workforce of around 20,000 to 30,000 people worked on the Great Pyramid for about 20 years. As the final block, the pyramidion capstone possibly covered in gold or electrum, was placed on top, the main construction was complete. The ramps were dismantled, and the pyramid stood in all its glory. What we see today is the weathered core structure. The smooth, white casing stones were stripped away over the centuries, repurposed for buildings in nearby Cairo. But imagine how it must have looked 4,500 years ago. A gleaming, white mountain, its golden tip catching the first and last rays of the sun. The construction of the pyramids was not just a building project. It was a triumph of human ingenuity, organization, and collective effort. It showcases a deep understanding of mathematics, astronomy, and physics. From leveling the desert floor to quarrying and transporting multi-ton blocks, and lifting them with precision to dizzying heights, every step was a testament to their incredible skill. The pyramids are not just tombs for ancient kings. They are timeless monuments to what humanity can achieve when we work together towards a common, audacious goal. Thank you so much for joining me on this journey back to ancient Egypt. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into the greatest mysteries of history. Let me know in the comments what ancient marvel you'd like to explore next. Until then, stay curious. Have you ever looked at a picture of the Great Pyramid of Giza and just wondered how? How did an ancient civilization, thousands of years ago, build something so massive, so precise, that it's still standing today as the last wonder of the ancient world? Well, get ready, because we're about to travel back in time to uncover the secrets of this architectural masterpiece. The story begins around 4,500 years ago, during Egypt's Old Kingdom, specifically the 4th dynasty. The man with the plan was the pharaoh Khufu. For the ancient Egyptians, pharaohs weren't just kings. They were considered divine beings, gods on earth. Their journey into the afterlife was incredibly important, and their tombs had to be worthy of their status. The pyramid wasn't just a tomb. It was a resurrection machine, a gateway to the heavens. Khufu wanted to build a staircase to the stars, a monument that would ensure his eternal life and stand as a symbol of his power forever. And boy, did he succeed. The location chosen was the Giza Plateau, a solid bedrock foundation on the west bank of the Nile River. This was crucial. You can't build the world's tallest structure on soft sand. The west bank was also symbolically important, as the sun set in the west, representing the land of the dead. Now for the big question. How did they build it? Let's start with the materials. The pyramid is made of an estimated 2.3 million stone blocks, mostly limestone and granite. The core of the pyramid used yellowish limestone quarried right there on the Giza Plateau. But for the outer casing, the builders wanted something special. They used fine, white Tura limestone from quarries across the Nile. This casing would have been polished to a brilliant shine, making the pyramid gleam like a jewel under the Egyptian sun. Imagine seeing that from miles away. And for the king's burial chamber, deep inside the pyramid, they used massive blocks of red granite, some weighing up to 80 tons. These were transported all the way from Aswan, over 500 miles to the south. So how do you move an 80-ton block of granite with ancient technology? The latest research suggests they used a combination of brute force, clever engineering, and lots of water. Hieroglyphs depict huge statues being pulled on sledges by hundreds of workers. They would pour water on the sand in front of the sledge to reduce friction, making it easier to pull these colossal weights. For the granite from Aswan, they likely used large wooden boats to transport the blocks down the Nile River during the annual flood season, when the water levels were high enough to bring the boats closer to the construction site. But getting the stones to the site was only half the battle. How did they lift them hundreds of feet into the air? This is one of history's greatest debates. For a long time, people believed they used a single, long, straight ramp. But the problem is, for a ramp to reach the top of the pyramid at a gentle slope, it would have to be over a mile long, requiring more material than the pyramid itself. So, archaeologists now favor other theories. One popular idea is a spiral ramp that corkscrewed around the outside of the pyramid as it was being built. Another compelling theory, proposed by French architect Jean-Pierre Houdin, suggests an internal ramp. According to this idea, they used a short external ramp for the bottom third of the pyramid, and then constructed a spiral ramp inside the pyramid's outer walls to haul the blocks for the upper levels. This would explain why we haven't found evidence of a massive external ramp. It is a fascinating theory that uses the pyramid's own structure to solve the mystery of its construction. Let's talk about the workforce. Forget the Hollywood image of slaves being whipped. The builders of the pyramids were skilled Egyptian laborers. Archaeological discoveries of a workers' village near the pyramids have revealed how they lived. They were well fed, receiving daily rations of bread, beer, and meat. They had medical care. Skeletons show evidence of healed broken bones. These were respected craftsmen, organized into crews with names like the Friends of Khufu or the Drunkards of Menkaure. Building the pyramid was a national project, a form of religious devotion and civil service. It is estimated that a workforce of around 20,000 to 30,000 people worked on the pyramid for about 20 years. The precision of their work is what truly boggles the mind. The base of the Great Pyramid is almost a perfect square, with the sides aligned almost exactly to the cardinal directions: north, south, east, and west. The difference in length between the longest and shortest sides is less than 8 inches. How did they achieve this without modern surveying equipment? They likely used simple but effective methods involving the stars. By tracking the movement of a star in the night sky, they could create a perfectly straight line in a true north-south axis. They used tools like square levels and plumb bobs to ensure the blocks were perfectly horizontal and vertical. It was a masterpiece of ancient engineering and astronomy. Let's take a look inside. The entrance is on the north face, leading to a descending passage that goes down into the bedrock beneath the pyramid, ending in an unfinished subterranean chamber. But this was likely a decoy. An ascending passage, hidden behind a stone block, leads up into the heart of the pyramid. This passage opens into the spectacular Grand Gallery, a towering, corbelled hallway that is a marvel of architecture in itself. At the top of the Grand Gallery, you reach the king's chamber. This room is built entirely of red granite. Above it are 5 stress-relieving chambers, ingeniously designed to distribute the immense weight of the pyramid above and prevent the king's chamber from collapsing. Inside, the only object ever found was a massive, empty granite sarcophagus. Khufu's mummy and his treasures were likely stolen by tomb robbers thousands of years ago, a fate that befell most pharaohs' tombs. There are also two other main chambers: the so-called Queen's Chamber, located below the King's Chamber, which was likely a storage place or a shrine, and the aforementioned subterranean chamber. Mysterious shafts also extend from the King's and Queen's chambers towards the outside of the pyramid. For a long time, they were thought to be for ventilation, but now they are believed to be symbolic shafts, allowing the pharaoh's soul to travel out to the stars. For over 3,800 years, the Great Pyramid stood as the tallest man-made structure on Earth, only surpassed in the 14th century by the Lincoln Cathedral in England. It's a testament to human ingenuity, organization, and the power of a shared belief. It was built with simple tools, but with an incredible understanding of mathematics, astronomy, and engineering. So the next time you see the Great Pyramid, don't just see a pile of stones. See a symbol of ambition, a feat of incredible logistics, and a precisely aligned celestial clock built by tens of thousands of skilled workers who dedicated their lives to creating an eternal home for their king. It's a story of human achievement that continues to inspire awe and wonder 4,500 years later. Thanks for joining me on this journey back to ancient Egypt. If you enjoyed this deep dive into history, make sure to hit that like button and subscribe for more adventures into the past. Let me know in the comments what ancient mystery you want us to explore next. See you in the next video. Have you ever stood before a mountain, not made by nature, but by human hands? Imagine a structure so colossal that for nearly 4,000 years, it was the tallest man-made object on Earth. This is the Great Pyramid of Giza, a testament to what we, as a species, are capable of. For centuries, we've looked at the pyramids and asked, how? How could an ancient civilization, armed with what we consider primitive tools, achieve such a feat of engineering? The sheer scale is mind-boggling. Over 2 million stone blocks, some weighing as much as 80 tons, were quarried, transported, and lifted with astonishing precision. Each block is cut so perfectly that you can't even fit a piece of paper between them. The pyramid isn't just a pile of rocks. It's a masterpiece of mathematics and astronomy. Its 4 sides are almost perfectly aligned with the cardinal directions: north, south, east, and west. The base is an almost perfect square, with the difference between the longest and shortest sides being less than 8 inches. How did they achieve this without modern surveying equipment? Many theories have been proposed, from long, straight ramps to spiral ramps wrapping around the pyramid. Some even suggest internal ramps. Recent discoveries using advanced scanning technology hint at hidden chambers and corridors, adding another layer to this ancient puzzle. But what we know for sure is that this wasn't the work of aliens or a lost super-civilization. It was the work of people. Tens of thousands of skilled workers, not slaves, as once believed lived in a well-organized city near the construction site. Archaeologists have found their bakeries, their workshops, and even their tombs. These were masons, engineers, and laborers who dedicated their lives to a project of national importance, a project that would echo through eternity. They were driven by a profound belief system and a vision set forth by their pharaoh, Khufu. They developed sophisticated techniques. They used water-filled trenches to level the foundation. They used copper tools, hardened with arsenic, to cut limestone. For the harder granite, they pounded it with dolerite, an even tougher stone. They likely used a system of sledges, rollers, and immense manpower, lubricated by water poured on the sand to move these massive blocks. It was a symphony of ingenuity, planning, and raw human effort. Think about the project management involved. It required feeding, housing, and organizing a workforce the size of a small city for over 2 decades. It required quarrying stone from sites hundreds of miles away and transporting it up the Nile. It required a level of architectural planning and execution that would challenge even modern builders with all our technology. The Great Pyramid stands as a powerful reminder. It tells us that the limits we perceive are often just illusions. It shows us that with a unified vision, incredible determination, and a refusal to accept the impossible, humanity can achieve the extraordinary. When we look at this ancient wonder, we're not just looking at a tomb for a king. We are looking at a monument to human potential. It challenges us to ask ourselves, what great things will our generation build to inspire the future? Thanks for watching. If you're as fascinated by human ingenuity as I am, make sure to like, subscribe, and hit that notification bell for more stories of incredible achievements.